All right, so section 3.5, derivatives of trig functions. So first we're going to start off by remembering two functions when we actually did the limits. Now we didn't really go over this one too much, but we're going to look at it right now. And if you remember, we actually had to find the limit of sine of something over something. If you guys remember, I taught this to you as a sine of a heart over a heart. And the limit, as long as these somethings were the same, was 0. And the reason why was because when you graph this function, just going to move this in a little bit. So when you graph this function, that's kind of what it looked like. All right, so I'm going to graph just a rough sketch of it right here. And basically, remember on the side it kind of did one of these, and then it kind of came up towards 1, and then it came back down, and then it continued on. So this function, we're actually going to find the limit down here, but the limit as x approaches 0, you can tell, is 1. Now if you graph the second one in the graphing calculator, I'm not really going to graph it in the calculator, you guys can do it to see, but this one does kind of the same thing, except as it approaches 0, it goes to 0, okay? And then as it goes to infinity, it gets closer and closer to 0. So find the limit as x approaches 0 for each of the functions above. So the limit as x approaches 0 for sine of x over x, from the graph, we notice that it's 1. And then the limit as x approaches 0 of cosine of x minus 1 over x is equal to 0. Now basically what this is telling us is that the derivative, so the dx, because remember, as x approaches 0 or as h approaches 0, it kind of means the same thing, and this would be h over h. So the derivative of sine of x over x is going to be 1, and the derivative of cosine of x minus 1 over x will be 0. Okay? Now this is extremely important to know, and you basically have to memorize these. So these two functions need to be memorized. So anytime you see cosine of x minus 1 over that same x, so it could be cosine of 3x minus 1 over 3x. That's also going to be 0. So as long as these two parts are the same and these two parts are the same, this is the derivative that goes with it. Alright, so let's recall. If you remember the sum formula for sine of A, if you remember Sinbad and Costella from last semester and last year, but Sinbad would want to sit with Costella, so sine of A, cosine of B, and he's going to assume the date is positive, and then he'll put his friend, sine of B, with Costella A, cosine of A. And then for cosine, Costella, her seating arrangement would be with her girlfriend, so it's going to be cosine of A, cosine of B, minus, they're going to assume the date is going to be horribly wrong, over sine of A and sine of B. Okay, so remembering these two is going to be key in this section because you are going to have to use it when you're deriving. Okay, we kind of already did this in a previous example in class, but if you graph sine of x and its derivative, let's make a conjecture about what function is the derivative of sine of x. So here, I'm going to graph sine of x. All right, and if we remember, sine of x starts at 0, and then at pi over 2, we're going to go to 1. At pi, we're going to go back to 0. At 3 pi over 2, it's down here. And then at 2 pi, we're back up to 0. And then it kind of does the same exact thing on this side. At negative pi over 2, we're at negative 1. Comes back up. Goes up to 1. Comes back to 0. Alright, so this right here is y equals sine of x. So remember, the derivative is the slope, correct? So, if I graph the derivative of sine of x, I see that at negative pi over 2, the slope is 0. I'm going to graph the easy slopes, okay? And then at pi, at 3 pi over 2, the slope again is 0. And same thing on this side. At negative pi over 2, the slope is 0. And then at 3 pi over 2, so not here, but here, the slope again is 0. So what is the slope at 0? The rise over run is going to be 1. Okay, so if I pick 2 points, it's rise, run. So the slope is 1. Basically, it's half over half, but it's still 1. And the same thing is going to happen here. So at negative pi, it's going to be 1. Or sorry, at negative pi, it's actually going to be negative 1, because it's a negative slope. So negative 1. And then at 0, it's going to be a positive slope, so it's 1. And then at pi, it's also going to be a negative 1. And we draw the graph, and what do you notice this graph is? Okay, we notice right off the bat, you should have paid attention, you should kind of know your sine and cosine, but the derivative of sine over x is actually, so the derivative of sine x, I should probably write it like this, so the derivative of sine x is the same as cosine x. So that's going to be one of the trig derivatives that you need to know. Okay. All right. So we're going to use the definition of derivatives to prove this, that sine of x is equal to cosine of x. So if you remember, it's the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, and so this is the function that I'm working with. So first off, I'm going to plug in x plus h into x. So it's sine of x plus h minus sine of x, all of that over h. So you see here, we're going to use the sum property of sine of Sinbad to break this apart, because we can't find, we need to simplify this as much as possible. So this ends up being, it's Sinbad, so Sinbad's going to want to sit with Costella, so it's sine of x cosine of h plus sine of h cosine of x minus sine of x. All of that is over h. All right, next thing I'm going to do is I notice that I have a sine of x here, and I have a sine of x here, so I kind of want to just move things around so that this sine of x is closer to this one, so I can factor out a sine of x. So I'm just moving sine of x, cosine of h. I'm moving this guy over next to them, so minus sine of x, and I'm just moving this guy over a little bit. So sine of h, cosine of x. All of that is over h. So basically what this allows me to do is kind of separate these two, and look what I can do here. They both have a sine of x in common, so I can pull out a sine of x, and what I'm left with is cosine of h minus 1 plus sine of h cosine of x. And all of that is over h. Alright, now looking at this, it doesn't look like we can do much. But what I'm going to do right now is basically split up the fraction to everything. So this is going to be sine of x sine of x, and remember, because these two are multiplied, I'm going to do this. Cosine of h minus 1 over h. Now the reason I'm doing this is because remember that the limit that I just set to memorize, and since they're multiplied, the h is not going to go to both, because if there was an h here, that means there would be h squared. And then plus, same thing here. Who do you think I'm going to give the h to? The sine or the cosine? Good. It's going to be to sine, because you guys notice that this looks like that limit that we were talking about a second ago. So now, what am I left with? Sine of the limit as h approaches 0, right? So we know, what is the limit as h approaches 0 of this guy? It's 0. Plus, what is the limit as h approaches 0 of this guy? It's 1. 1 times cosine of x. So what happens to this? What is sine of x times 0? 0. Plus 1 times cosine of x equals cosine of x. And that's how we know that the derivative of sine of x is equal to cosine of x. And of course, you don't have to do all of this, but this is the proof for that derivative. Okay. Oops. Oh, I'm missing a page, but here it is. Okay. These are derivatives that you do have to memorize. The derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. The derivative of tangent of x is secant squared. The derivative of cosecant of x is negative cosecant x cotangent x. Derivative of secant of x, secant x tangent of x. And the derivative of cotangent of x is negative cosecant squared of x. We'll talk about the helpful rule to memorize these on Monday. I'll give you guys a mini handout for it as well. So let's actually start doing some examples. I think that example is not here. Okay, it's okay, I'm going to write it right here. So, example 1. Find the derivative of 6x squared minus sine of x. Now this is easy because there's no multiplication involved. This is a subtraction, so we can just use the power rule. So what is the derivative of this guy? 12x. And then minus, what is the derivative of sine of x? Cosine of x. Done. That's the answer. Okay. Number 2 is find the derivative of 3x times secant of x plus 1. All right, now you could start off with the product rule and just separate these two, but what I'm going to do is I'm actually going to distribute this first. So this is 3x secant of x plus 3x. Now I'm still going to use the product rule here, but at least I don't have to worry about it here. All right, so let's start off with the product rule. So if you remember, it's going to be the derivative of the first guy, okay, or I'm sorry, the first guy, which is 3x, times the derivative of secant of x. And from our table, we know that the derivative of secant of x is secant x tangent x. And then plus the second guy, so secant x, times the derivative of the first guy, which is times 3. And then plus 3x, what is this derivative? So it's just going to be plus 3. All right, and then what do you notice in all of these terms? I'm just going to clean this up a little bit. Instead of putting this times 3, I'm going to put the 3 at the front. So this is 3x secant x tangent x plus 3 secant x plus 3. This is basically the final answer. You can clean it up a little bit by noticing that there is a 3 in every single term. So we're left with 3 times x secant x tangent x plus, take out the 3, so secant x, plus take out the 3, 1. And that is it. I mean, it's an ugly looking answer, but it's still the answer. That is the derivative of that function. All right, moving on. So we're going to find the derivative of secant x oh, I stapled these wrong. Sorry. Let me double check this, how I stapled this thing. Alright, so that's the jerk. Oh, there they are. Okay. I just stapled these wrong. I thought they weren't there. Alright, number 3. Let's find the derivative of cosine of x over 1 plus sine of x. Which actually, I'm going to need a little bit more room than just what's over here. So it's kind of a good thing I didn't write it on this. So I'm going to do this over here. Alright, so the first thing, it's the bottom. So 1 plus, because this is division, so I'm using the quotient rule. So 1 plus sine of x times the derivative of the top, which is negative sine of x. And then minus the top, which is cosine of x, minus the derivative of the bottom. Okay, so what is the derivative of this bottom? The derivative of 1 is 0, and the derivative of sine of x is cosine of x. So it actually cleaned up pretty nice. And then all of that is over 1 plus sine square, 1 plus sine x squared. Remember the bottom squared. All right, so when we clean this up, I'm going to distribute this negative sine of x to everyone. So this is negative sine of x minus sine squared of x. And then this is minus cosine squared of x. And all of that is over 1 plus sine x squared. All right, so looking at this, I don't want you guys to think that this is it, because remember cosine squared. Okay, where did we see this before? It's part of the Pythagorean identity. Do you remember this? Cosine squared of x plus sine squared of x is equal to 1. So if I can change cosine squared to something with sine squared, then maybe I can cancel out that sine squared. So, and I can. Cosine squared of x is the same thing as saying 1 minus sine squared of x. So I can rewrite this. Negative sine of x minus sine squared of x minus 1 minus sine squared of x over 1 minus sine x squared. Now be careful, these two are not the same, okay? But what I can do now is, look at this. The negative sine squared of x minus another negative sine squared of x is the same thing as saying negative sine squared of x plus sine squared of x, which makes these guys disappear. So then what we're left with is negative sine of x minus 1 over 1 minus sine x squared. Now if I flip this guy around, all right, I end up with a negative, because I kind of see this problem right there, so I can maybe cancel out one of them, but there's a way to do this. So negative 1 minus sine of x, and all of that is going to be over 1 minus sine x squared. And basically, oh, I keep on writing plus. It's supposed to be a plus here. You notice that if I take out a negative, what am I going to be left with? So if I take out a negative 1, or a negative, I have 1 plus sine x over 1 plus sine x squared. So you notice that these two are the same. So this is gone, and one of these are gone. So my final answer is negative 1 over 1 plus sine of x. Final answer. Now this is as hard as it's going to get in these problems. All right, let's find number 4, because I have completely stapled these in the wrong order. All right. So number 4 looks harder than it really is. All right, but you notice that these are two things that are multiplied, so I'm going to have to use the product rule here. Okay, and then this one's going to be easy, so we'll come back to that one. So let's start off by finding the derivative of this part. So the derivative of this is the first guy, which is theta, times the derivative of the second guy. And the derivative of sine, we now know, is cosine of theta. Plus, we're still here, so plus the second guy, which is sine of theta, times the derivative of theta. And the derivative of theta is the same thing as saying the derivative of x. And the derivative of x is just 1. And then plus the derivative of this guy, all by himself. So that's going to be actually negative sine of theta. So when we clean this up a little bit, this is going to be theta cosine of theta plus sine theta minus sine theta. And what do you notice happens to these two? Right? They're gone. So all we're left with is theta cosine theta, and that is your derivative. So our d dx is that. All right, the video is getting kind of long, so I'm going to stop here for this one. I will make a part 2 video that you can watch maybe. You still have to watch it before Monday, but on a separate occasion. All right, enjoy these to, and actually the next video is going to be extremely short.